Hi. Now that you've taken the quiz and you are extremely irritated at me, let's go ahead and move on. Let's take a look at ellipses. I actually hope the quiz wasn't too bad for you. Just a few reminders on circles and parabolas. So here is the formula for an ellipse. Now the good news for you is that you can use the app to do most of what you need to do for the ellipse, but bottom line is you have to know how to complete a square in order to be able to do nearly anything with conic sections. Now, this is the formula, the standard formula, and I'll give you a minute to write that down for an ellipse. Now, you're going to see in general form, which is in the long form, that an ellipse is going to look a whole lot like a circle in general form. The main difference, and really the only difference, is that the coefficients on the squared terms are going to be different. So whatever coefficients on the x squared term is going to be different than the coefficient on the y squared term. If they're the same, then you know it's a circle. But a circle is a version, actually let me rephrase, excuse me, a circle is a version of an ellipse. It's a special kind of an ellipse. Because an ellipse is just a squished up circle. Okay? That's an example of an ellipse. Looks kind of like an egg. Standard form, H and K stand for the X part of the center and the Y part of the center. So you're going to start with your ellipse on finding the point HK, which is going to center that ellipse. And here it is in standard form. Now we've got to complete a square to go from that general form to ellipse form. And I'm kind of using vocabulary intermittent, but like from general or standard form to ellipse form, you have to complete the square so that you can get your center HK. Now A, this denominator, notice it's A squared. So you'll take the square root of whatever's on the bottom here to get A, and that's half the width of the ellipse. So I'm going to color code this. From here to here will be your A. From here to here will be your B. Half the width is A, what's underneath the x squared term, and half the height is going to give you this, which is what's underneath your y term, once it's in the completed square form. So thinking we may be to the point where we can do an example, because this is very similar to what you've already talked about. So this is a simple one. I have it already done here, so let me go back to an empty slide. 4x squared plus y squared equals 36. Okay, so you can recognize this as an ellipse in the fact that you've got a plus in front of each squared term. They're both positive. They're the same sign. Also, there's coefficient on the x squared term, and it's different than the coefficient on the y squared term. So, ellipse. Squished up circle. So now to get it into correct form, first of all, you need a 1 here, and then you need these two squares completed. So, let's get a 1 there first. And actually, that's the last step. But we don't need to complete any squares because we don't have any x terms. This is quite an easy, well, it's a pretty simple example. So 4 goes into 36 9 times. So x squared over 9. 1 doesn't go into 36 at all. Goes 1. So now we're in ellipse form, and we have a 0 and a 0 with our two completed square terms. So that's the center. And then we said that A was the term underneath the x squared, but we had to take the square root of this. This is A squared. So A squared equals 9 indicates that A is 3. So the general wideness of this ellipse is 3, and B squared, is 36, so B is 6. So that's the general tallness quotient of the ellipse. So to draw it, we're going to start with the center, and then we'll go 3 to the right, 3 to the left. Put circles there to indicate points. We got 6 down, 6 up, and there's our ellipse. Now when you use the app, you're going to have to be careful how you enter these in, because the a has to be underneath the x squared and the b has to be underneath the y squared. And I don't have the app on here, so hopefully you can figure that out on your own, but just make sure it's entered in correctly. The next thing that they want you to do is to find the foci for that ellipse, and we're going to have to use the program to get that done. So I'm going to pause this for just a second and get out my calculator and get everything put into it. Well, actually, we don't need to pause. Calculator, right here. So you go app, conic, run it. It's an ellipse, and you have two options. You have x squared, or x minus h squared over a squared plus y minus k squared over b squared equals 1, or x minus h squared over b squared plus, and that's for a taller version. Now you can put in either of these, but it's a lot easier to put the bigger term first, just with this app. So the bigger term here, you'll notice, is the one that's underneath the y squared term. So we're going to choose the tall ellipse. So I'm going to choose number 2. Enter in your a, which look up at your standard form. 36 is underneath the y squared term. A is underneath the y squared term in the app. So we're going to put the 6 in there, and we're going to put the 3 in for B. H is 0, K is 0. Graph it. Okay, if you're having trouble seeing it, go to Y equals, go to your window, actually go to your zoom and do zoom conic. That will enable you to see it. There it is. And then go to Y equals, and from that menu, I believe it's alpha enter, and that should give you the foci in the center. So, according to my calculator here, center was 0, 0, which we already established. The foci, 0, negative 5.196, and second foci is positive 5.196. Okay, so those are roundabout here and here. There's a formula to compute those, and the formula is in the textbook. And it's a pretty easy computation, not very complicated. Foci is c squared equals a squared minus b squared. So basically just plug into your formula there and solve it for c squared. So it's c units from the center. Center 0, 0, and it's oriented up and down. So c squared equals a squared minus b squared. Put your first one, your biggest one in first. That's probably the easiest. A squared was 36, b squared was 9, which makes for 27. So c is square root of 27, plus or minus, and you're going to find that to be right around 5.196. Just going to double check that. So that's it. I mean, that's just the formula. And if it's a tall one, your foci goes up and down from the center. If it's a wide, then your foci is going to go on the horizontal axis, so you'll go right and left to get to this point. So we go from 0 on the y-axis up square root of 27 and then down square root of 27. So that's how the app works to find the foci. We'll go through another one of those on Monday, or Tuesday, sorry, Tuesday. But here's another example. Recognize it as an ellipse because we have a coefficient for the x squared term plus a y squared term with different coefficients. So let's go ahead and complete the square first. How much time have I used? 9 minutes. Okay, I'm going to do a little NASCAR-y math here. Put your x terms together. Put your y terms together. Leave the 15 on the other side. We've done this with circles, so it shouldn't be new. Here, you've got to pull the 4 out to the front, factor it out. Don't forget to factor it out of both terms, and then leave a blank spot for the completed square. Again, half of 16 or excuse me, half of 4 squared is what you'll complete that with. But divide by 4 for your x coefficients. The leading coefficient for the y is just 1. So divide both terms by 1, leave a space, and then complete your squares. So I'm going to make it a different color so you can clearly see. Half the middle term, 2, squared, 4. So you're going to add 4 to the left side. Now when you do that, you're going to add 4 to the right side, but be careful. It's not technically 4. 4 here, 4 here, 4 distributed through there is actually 4 times 4 is 16. I'll just write it as 4 times 4. Okay? And then here, half the middle term is 3 squared is 9. So to complete that square, we're going to need a 9. So we're going to add 1 times 9 to your right side. Hopefully that's clear. Here we go. Completed the squares, x minus 2 and y minus 3. Add all that junk together, it's 31 and 9 is 40. And then, just like before, our last step is divide both sides by the 40, because we need a 1 here. That's the last step. There it is. So, x minus 2 squared over 4 goes into 40 10 times. Okay, so y minus 3 squared over 40, and then 40 divided by 40 is just 1. We're done dealing. This is going to be the bigger number. That's the up and down. So again, we're oriented tall. So square root of 40 is your tallness quotient. Square root of 10 is your wideness quotient. This is right around 3. This is right around 6. Okay, so we're going to center though. We're going to start the ellipse at 2 and 3, opposite sign, 2 and 3. So 1, 2, 1, 2, 3. There's the start of the ellipse. Now for tallness, we're going to go down 6 and up 6. It's actually 6.1, but whatever. 1, 2, 3, 4, 5, 6.1. 1, 2, 3, 4, 5, 6.1. Okay, and this is around 3.1. So let me draw the center as an X. 1, 2, 3-ish. 1, 2, 3-ish. So there's your ellipse. Foci, you can use your app. I'll just show it by hand because it's pretty quick deal. C squared is 40 minus 10. A squared minus b squared, which is 30. So C is square root of 30, which means your ellipse is going to be square root of 30 away on the major axis, the tall axis, from the center. So that's 5.47, 5.48, let's call it. So my foci are going to run here and here, which is 5.48 from 2, 3. So they're going to lie along the 2. 2 will be the first coordinate, and then you take your 3 plus 5.48, so that's 2, 8.48, and then you'll do the same thing, 2, and then 3 minus 5.48, which again is a pretty, well, that's a little harder calculation. Negative 2.48. So there you go. And I have all that stuff listed down there as well. Okay, there's your assignment. Get started on it. It's 677, 1 through 25, every other odd. So happy hunting. If you need to watch this again, I'll post it on YouTube so that you have no issues with watching it again if you missed anything the first time. Anyway, have a good weekend, and I'll see you on Tuesday.